Hey, thank you for joining us on today's Tech Talk. My name is Jason Lee. I'm a Senior Principal Solutions Architect with Equinix. And today we are joined by John Gentry from NVIDIA. And John, do you mind giving us an introduction?
Absolutely. And thanks for having me. I'm looking forward to the discussion. John Gentry, I'm with NVIDIA. I'm on our AI Factory technical sales and strategy team. So really responsible for understanding enterprise requirements, their challenges, and how we can help solve their problems. So this should be a timely discussion.
Yeah, great. So let's go ahead and get started. So the AI hype cycle has been around for a while now. Maybe if John, you can give us a kind of a history of how kind of where we are and how do we get here?
Yeah, I can try. There's a lot to cover. It's certainly it's an interesting time because, as you mentioned, that the AI hype cycle seems to get new life every once in a while. So obviously, AI had its iPhone moment, as Jensen likes to say, when the launch of ChatGPT and the exposure of sort of what a large language model is capable of to the broader population. That I think caught a lot of attention. I think there was a lot of question around how will this be used, both by society and also by industry. That was a few years ago now, right? And so that initial sort of energy has kind of turned into reality of, okay, now what truly can we do with these? What's the practical application of AI? And that's, I think, what we're starting to see now is a move from what I would call experimentation and discovery to practical application and actual use in a business context. I think it's important to note there was a whole lot that came before that iPhone moment. Um, you know, the evolution of scientific computing and traditional HPC, moving into more generalized applications. We could get into the technology. I know it's a tech talk, so moving from having to have labeled data sets to train with to unlabeled, unstructured data for training, and now you can train on the internet at large. The introduction of transformers, and then the evolution of GPU compute power, and the sort of application of those sort of approaches and capabilities. So there's a lot of technology that went into that moment.
Yep.
It's continued to advance and get more and more powerful. And I think that's what's unique about this hype cycle. A lot of hype cycles, there's this inflection point, then the technology doesn't change substantially for some period of time. With AI, there was an inflection point. It generated a hype cycle, and it seems that there have been continued inflection points, ongoing enhancements, developments, innovations that are really challenging enterprise to keep up. But we are at that point now where I think it's proven itself.
Yep.
What do we do with it, right?
Yeah. Yeah. So, what would you say is like the latest inflection point that we've hit?
I'd say there's a couple. I think everyone remembers the DeepSeek moment from I think it was last year at this
Yep.
point, right?
Yep.
But it was the introduction of reasoning. I think it's important to step a little bit back from that, though. I think we've seen what we describe at NVIDIA as sort of three scaling laws of AI. The first was sort of pre-training. So how do I go and take as much data as possible, train a model on all that data, and create sort of a general purpose large language model, something that we would equate to a well-educated high school student, or maybe even as it advances, someone coming out of college with a general sort of Bachelor of Arts in social sciences, right? They can answer a lot of questions generally, but they aren't specialized, right? They aren't unique to, say, a vertical market or a particular application like biology or life sciences. That was sort of the pre-training, and we saw massive investment from primarily hyperscalers, the large model builders, right? The open AIs, obviously, as well as the cloud providers into building those models. I think Meta did the world a big favor when they open source Llama, which would be considered one of those foundation models, right? The second wave, because everyone's not going to be able to invest in the compute or garner enough data to go train a foundational model. Right. Sort of the second wave was what we would call that sort of post-training, which is, okay, I've got a foundational model or I've got an approach or technique, Now I want to train more specialized capabilities. And there's a couple of approaches to that. Early adopters in enterprise that we saw, I think, went ahead and did train models from scratch on very specific data. So that's true in, say, life sciences. Biopharma is a great example. Some financial services organizations looking to model, say, fraud detection, where some of these practices, the scientific compute, were there in the organization already, so they had some of that DNA built in. But for the most part, customers were either trying to leverage a large language model through application integration, or they were taking a model like that and fine-tuning it or retraining it with proprietary data. So now I have a general intelligence that is, and that's I need to be careful using that term because that's taking on a whole nother sort of hype cycle. So we'll say generic intelligence and specifying it to a company. So now I have an expert on, insurance, or I have an expert on call center capabilities or customer support. That drove a whole nother wave of scaling, this fine tuning, and this ongoing, we're starting to see iterative cycle of train, leverage, understand, fine tune, and so forth. The third law of scaling is what we're in now, which is the result largely of that DeepSeek moment where they introduced the world to this concept of reasoning, or allowing a model to not just get a prompt response, but actually get a prompt, generate a response, and then check that response for its accuracy, its validity. Think about it longer, give it more time to contemplate. And the compute required for that is now exponentially greater. But obviously the outputs can be, exponentially more powerful. So we're seeing sort of these three phases, and that goes back to, at each phase, there's more specific application to enterprise or just specific businesses and vertical markets. And there's more depth of capability in the models and the technologies themselves.
Yep, great. And I think just to level set for some of our audience that may be new to the subject, where you talked about some of the scaling laws here, I believe the second law you're talking about really is around what, for our audience, may have heard the term RAG for several years, right? Retrieval augmented generation. Is that kind of that stage?
It came in the same time frame. I think what you're seeing in RAG, and RAG is a great, what I would call, fast path to applying AI in a business context or in a specific context for a company or market, right? RAG is taking a model and allowing it to say, I have this general understanding, but I want context-specific understanding, either something that's more specific on subject or more timely in terms of, this data is new, I couldn't have trained on it. Mm-hmm. It'll go retrieve that information and augment its response with that context-specific knowledge, hence retrieval augmented generation. It inserts new data into the response process, but not as a part of the training. It's actually augmenting a trained response with specific data. When we think about retraining, it's, okay, RAG was valuable, but instead of having to wait or make available all this auxiliary information, vectorize the data, put it in a data store, understand how to index it and search it while I'm responding to a prompt, that works if you have a limited number of requests, right? Or some time to wait. Retraining is saying, oh, I've identified a really good set of data that's net new, either by vertical or company. I'm going to actually now retrain my model on that data so that I don't have to retrieve it. It's there. It's natively in.
So right? It's built into the model.
Absolutely. It's kind of like, did I have to go to my notes, or did I study hard enough to be able to answer the question based on my knowledge?
Great analogy. So as you said, this reasoning model is now going to require a lot more compute. Does that kind of lend why we hear so much about this term of AI factories today?
So I think that what's driving AI factories, certainly the compute requirements, but even more so how those compute requirements, where they're being deployed and how they're being consumed. And so when we were doing large model training, largely by the hyperscalers or by folks that are in the business of building large scale data center infrastructure,
Right.
right?
Yep.
Um, it was more custom. It was more build to order, and it was massive considerations, massive projects. We've been involved in quite a few,
Yep.
some of which I can and can't talk about. But when you think about AI Factory, I think it's a concept to help enterprise, in particular, understand that this is a new method of deploying something that's going to generate value. In the same way you might build a factory to produce goods, now you're building a factory to produce intelligence or outcomes from a compute perspective. And that needs more confined or more defined parameters, right? So at a
Yep.
high level, we used to think about raw materials and labor and power going into a factory and finished goods coming out of that factory. It's not a lot different. The difference is the raw materials data, right? You still need the power, and you still need, in the case of that applied intelligence or expertise, a lot of times that's software now. Maybe it's a foundational model that's being plugged in. Maybe it's some capabilities around ML ops or a
Right.
pipeline or the ability to evaluate outcomes that live in that factory, along with compute and network and storage. That's your core factory, and the output of that is intelligence or insights into your business or new products and services. And so it's really a way of helping enterprise understand I'm building something that's somewhat net new, but it can follow a historical analogy. But it's not traditional IT in the sense of building a general purpose thing that's going to support a bunch of business functions. It's being built for a specific purpose to produce intelligence and kind of needs to be treated a little differently as a result.
Yeah. So you talked about the use of AI now for those folks that are bringing these AI projects. Can you tell us a bit more about the actual personas that you're working with?
I think we've seen that evolve, right? In the same way that the use cases have evolved and where you would go to get sort of the capabilities from taking advantage of ChatGPT and OpenAI, which is someone else's model in maybe an API call or just a Q&A. NVIDIA, we have a long history of working with the early adopters, which were the data scientists, the AI practitioners, the scientific computing resources. Um, and in a lot of cases, their needs have been specialized. And so the infrastructure that was built to service those needs was specialized. And so we built a lot of small clusters in traditional organizations that were quite often held outside of the domain of IT because it wasn't a general purpose
Right.
business function. It wasn't supporting sort of broader business function. It was a dedicated deployment for the researchers or for the analysts or for the data scientists. At the same time, you had large scale deployments in the cloud providers primarily, and we've got a couple classes of cloud provider that we've seen emerge. Um, and they were building that compute to make it available to those data scientists outside the walls of traditional IT, right? So you had what we like to refer to as sort of shadow AI, right? I can remember back long enough that you had shadow IT,
Yep.
right? And now you had shadow AI. And so now you've got those sort of users as a persona that is sort of used to using this resource when they can get access to it. That's increasingly a constraint that's driving requirements back on what I would say is a new entrant into this game, which is enterprise IT, right? Enterprise IT is now saying, okay, we need to move out of the cloud for cost or data control or other reasons. We need to own this infrastructure, which means IT needs to understand, deploy, govern it. But this is new. It's been in a closet or in
Right.
a
Yep.
different corner. So how do they do that? And then there's a third persona that's I would call sort of executive governance, right? We've seen the emergence of chief AI officer sitting alongside a CIO, right? Or maybe it's a new function in the CTO organization, right? But they're responsible to the business for justifying the investment and return, right? So there's this sort of healthy tension, I would say, between the people that just want access to the resource to do their job, to drive innovation, to drive either cost savings or new product innovation, the traditional IT and IT operations folks that are trying to get a handle on this and figure out, how do I build a specialized factory versus a generic IT infrastructure? And then this executive that's got to govern what's the right balance between letting the practitioners use cloud or have specialized versus having this standardized. And I think one of the rises of AI factory is that consolidation, taking all that shadow AI and saying, we're going to build an AI factory that can bring these users to a resource that we can make available and manage the utilization and the access to, so we know we're driving a return on that investment.
Yep. And then putting all the safeguards that IT has, especially around enterprises who have those concerns.
Absolutely. And interestingly enough, this is a very active conversation right now within NVIDIA and with our customers when we think about what is the right, say, reference architecture for enterprise AI factory. A lot of times these AI factories, before we really called them that, lived on islands that was this dedicated compute resource. It was isolated. It was sort of firewalled off
Yep.
because it was training or it was fine tuning. As it moves to production and now it's driving inferencing, it means it has to connect to the outside world, which means all of a sudden now it has to comply with governance and security and be in many cases repeatable and standards based. And so we're working with a lot of the ecosystem very closely who have played that role for enterprise IT for a long time. Think about the big partners that are out there that understand enterprise IT operations. They're critical partners for NVIDIA now to bring that sort of resource for AI development to, enterprise IT operations and production deployment supporting an application, whether that's a new application that's driving new value, driving new revenue streams, or the application of the technology to drive efficiencies in operations or support or other things.
Do you see a trend as far as where these workloads are also running? When you mentioned hyperscalers multiple times, but now partnering with some of the traditional IT partners, how are customers looking at where they're going to run these workloads?
Interestingly, I just was in an executive briefing with a large manufacturer yesterday, and one of the things they said was, we've got many issues, please help. But if you listen to what their challenges are, one of the assurances that we can give them is that they are not alone in those challenges. They're the same challenges I hear from just about every customer at this stage of adoption, which is, I know I need to balance. Almost everything is going to be some sort of hybrid, right? Because I've got, there's certain capabilities in cloud that are necessary, certain sort of burst capabilities, but there's also an acknowledgement that a lot of this needs to live on-prem where I can control cost and I can control data, right? Data gravity is something that's increasingly important to consider, especially as you go from generic training to fine tuning, where now I've got proprietary data that's training my model. Or we're seeing now a rise of, I think, what's commonly referred to as agentic AI, which I think is misunderstood a little bit. Agentic AI really, to me, is more about giving the AI agency to take action, which means you may be asking one sort of LLM or model to be an arbiter to multiple models, to answer specific questions collaboratively to drive a better response, which involves some of the reasoning we talked about before. That's a very complex and interconnected process that's going to rely on a lot of different models with proprietary information, where response time and governance all is that needs to live sort of in a controlled environment, not
Right.
necessarily in a cloud, right? So as customers start to consider, there's a lot that comes into these considerations. Cost is certainly a major driver. We know on-prem, if you can drive high utilization, is a lower cost alternative, but doesn't necessarily have the same flexibility. But again, I think there's customers trying to figure it out based on ownership, cost, data gravity, and then there's the practicality of AI factories. They require a pretty significant footprint in terms of data center space, power, cooling. You all know that
Yep.
extremely well,
Like,
right? So I think we're starting to see an increase in the attention given and the importance of the underlying data center infrastructure as being critical to this, and that's a constraint right now. That actually we're seeing a lot of conversations
Yeah.
around Equinix.
And we hear a lot from partners and customers that a lot of their legacy data centers are just not able to handle the capacity and the density of the new infrastructure that's being released by both NVIDIA as well as our mutual partners.
Yeah, and in some cases you've got the classic paradigm of chicken and egg, right? The reality is the relative compute power to kilowatt for these new systems, it far exceeds traditional systems. So we
Yep.
talk about, oh, you know, so much power consumption. Well, if I'm getting 10x the compute for 2x the power, I'm actually 5 times more efficient. But I need 2x the power. The
Exactly.
challenge is, how do I deploy that before I can go decommission some of the traditional systems that may be being replaced by these more efficient accelerated compute infrastructures,
Yep.
right? And it's a timing game, and we're seeing a lot of trade-offs. I could think of one particular customer. You would expect, just from knowing them, that they would have very robust data center infrastructure, power and cooling available to them. But in fact, they can deploy sort of single AI system per rack where they used to have 10 to 12 traditional IT systems
Right.
per rack because of the power and cooling constraints, right? They can get more out of that rack, but this is driving different considerations, especially if you think back to where we started this, which is the hype cycle. It's a race right now. And when one of the big constraints is, I've actually got to build 4 walls and lay power to it, not to mention one of the other things, which is, how do I connect it?
Yeah.
You can't build a data center on an island, right?
Yeah. And that kind of to what you mentioned earlier around agentic sounds like there's going to be this need for a lot of connectivity so that the agent can get access to all of those things that you mentioned, and how do we connect to them privately, securely, and being in the realm of IT now, how do we make sure it adheres to all the IT policies?
Yeah. I mean, that is, we've mentioned sort of phases of adoption, and along with those comes certain maturity to each phase. I think we're in the early days, and we're honestly still in the early days of enterprise adoption in terms of building and deploying an AI factory that's purposefully there to service a specific enterprise, as opposed to making API calls to a chat GPT to facilitate a quick win,
Right.
right? Or even using RAG with a foundational model. Now we're talking about generating real custom capabilities, and all those considerations. If you think most of these are hybrid, now I need connectivity to the cloud, I need connectivity to corporate, I need to some centralization point for that so that I can connect to both securely. Now I need actually to expose that to some user base, whether that's my customers or my employees, or the society at large. Where's the closest place to do that? Proximate to my application or proximate to my user? Well, now I probably need to connect to multiple clouds, right? So that's going to be one of the things I think that we start to add to this sort of AI factory concept is what would be traditional supply chain logistics, right? It used to be you needed the right amount of highways or a river to get your
Yeah.
materials to the factory and your goods out of the factory into distribution. The highways and rivers are now wires, right? They're now connectivity and
Yeah.
cables, right?
Yeah, and I think that kind of goes into our partnership between Equinix and NVIDIA, why it's such a great partnership in the sense of you understand all of the things that AI customers need to do to get their AI projects and the ROI out there. But what Equinix is bringing to the table is like what you said, being able to provide that power density, stuff that our customers may not be able to have today or don't want to build net new to enable that infrastructure. But that connectivity, as you know very well, for Equinix is where we absolutely excel to be able to get customers that connectivity to their clouds in a hybrid AI environment, as well as their various locations. So that, to me, is Equinix's role in this private AI world.
I think Equinix, Equinix plays a key role. I would actually give you more credit than that. And now I've known Equinix for a long time, right? I think I first did business with Equinix in 2000. For context, that's like 25 years ago when you were in the building up the road a little bit. But there's the data center infrastructure, and one thing that we emphasize with our customers that are looking at investing in an AI factory, oftentimes they'll think about the compute and not realize the longest lead time that they need is the coolers and the power connections. Those are things that Equinix has built and ready, right? I mean, you have sort of the infrastructure to support an AI factory sort of at the ready. It's like the difference between going to a car dealership and picking your car and waiting for them to assemble it versus going and having it available on the lot, right? That's not quite on the lot because we got to build the compute in there, although we're working on that. The connectivity being a part of it. The other thing is, and you don't think we talk about this enough, the ability for you to partner with IT operations to provide some of the management capabilities. A lot of customers, a lot of this AI work's been done in the cloud, and they want a similar experience, but they want to own the infrastructure, right? And having to being able to have that sort of cloud operating model, which is someone else is going to deploy and manage this. I'm going to access it and use it, and it's mine. It's secure. My data can live there in perpetuity, but I don't have to actually go in and wait for alerts or other things, or I can, right? It's a very flexible model that Equinix provides. How much service do you need? And I don't think we talk about that enough because I do have customers that sort of live everywhere on that spectrum, right? They need the power and cooling, or they need, the power cooling and some level of connectivity. They need the full managed service because you know what? They need the factory stood up and their resources are busy, maintaining their existing business functions, right?
And no, thank you for that plug around our managed solutions. And I think, again, going back to our partnership, that is absolutely one of the things that we see as a huge differentiator that we are bringing out to the market jointly to be able to have customers get that experience, get that ability to focus on their actual workloads, the data, the science that they're trying to do, as opposed to worrying about infrastructure. And we've stood up a team to help customers with this new world infrastructure that we live in today.
Yeah, it's interesting. I've been in IT long enough. One of my favorite sayings is like everything old is new again in IT, and that's happening in a couple of ways with AI. Early days, and I won't mention what type of technology I was working on, but everything was very purpose built. You had a purpose built system for ERP, you had a purpose built system to run your finance or your billing if you're a telco, or your electronic health records if you were a provider of healthcare. Over time, those became very generalized, right? And you had this rise of general compute, the rise of x86 and VMware for virtualization. And you built this sort of general purpose resource that you made available to the enterprise and they could leverage it. Now, all of a sudden, with AI, we're back to building specialized infrastructure. It behaves a lot more like traditional client server than it does like, the last 10, 15 years of compute. Well, there are companies in that evolution that have only, migrated everything to cloud because it was all general purpose. Now they're realizing they have they need purpose built and they need sort of ownership. How do they move out of cloud without the operating experience because they've given that up by moving to cloud? That's where, that type of an offering can really add value and give them a fast path. Because I think time is of the essence. Again, this is one of the few hype cycles that doesn't seem to be burning out. It seems like every time I think it's going to fade, something new happens, some new innovation. I'm sure there's one right around the corner. We haven't even touched on robotics and like physical AI, and that's driving a whole new wave of growth that's exciting. So,
well, maybe that's a follow-up topic we can have next time.
Absolutely. The one that I'm really watching right now, because I hear a lot of sort of debate on my various sort of, what I read and consume, as well as conversations internally, is this agentic conversation, right? And I think there's this misconception that we have little AI bots that are like little agents and they run around and do what they're going to do in somewhat of a nefarious sense.
That's
versus
what I thought it worked.
well, but it's really, from my perspective, agentic AI is about giving AI agency to make decisions or execute tasks, right? So you're really empowering a model with some guardrails to go and source expertise from other models. And that's where we get into this rise of sort of mixture of experts or model, manager of models or multimodal inference. And this is driving compute, but it's also driving some unbelievable outcomes, right? And you just have to, take a minute to listen to Jensen, one of his EBCs, to understand where this is going from a compute perspective, and then the potential of it to really solve big problems. And so I think, it would be interesting to follow up in a few months and see,
Yep.
where are those approaches actually being deployed? How are they yielding results? I think the big question right now is, where's the ROI? And we certainly have customers that are driving very significant ROI, but they were the ones that adopted 2 years ago. So there's a whole nother wave coming for enterprise to actually take full advantage and then reap the full benefits of this.
Yeah, I think that is the ultimate question here. So with that, why don't we go and jump into some questions from the audience?
No, that would be great. I really appreciate the opportunity. One of the things I enjoy most is being able to share the experience I've gleaned from other customers with other customers. I think making those connections and helping people understand they're not alone,
Yep.
and then take advantage of common responses is key. So maybe
Yep.
we can answer some questions for folks.
This one we got from Pradeep. And he says, can you share any experience with AI factory deployments and what kind of to watch out for? I think we've both seen this.
We can. So I think there's a lot of demand right now. Frankly, some of those larger players that we mentioned are pre-buying up a lot of capacity. And so I would say be aware of lead times and lead times on some of the most boring aspects, right? I mean, I think the longest lead time we have right now is for, chilling distribution units for liquid cooled systems, right? I mean, it's like, 18 months. What? Right? I remember back 3 years ago, it was cables. Like cables. I'm waiting. I'm going to stand up a massive AI compute infrastructure and I'm waiting on the cables. So it's, sweat the little stuff in this case, right? So that pitfall, making sure, I think one of the measures that we use at NVIDIA in working with partners and customers is what we call time to first token, right? So how long does it take from when I make a decision, I'm going to build this, to I get my first token out of it, right? And so if you think in that context, Pradeep, think about everything that goes into that. There's the procurement cycle, there's the build or fit to data center infrastructure, which means power, cooling, rack space. Then there's the deployment timeline. There's a lot of supply chain logistics in that. Then there's the physical rack and stack. Then there's the software logical config and bring up. And then I would highly recommend there's a test phase, right?
Right.
Prove that, show me this cluster is running fully operational at optimal performance. That sign off and handoff at, cluster tested, cluster ready is time to first token, right? And so any one of those in that long chain that, gets extended pushes all of them out. And that would be the main concern, is just be aware of the interdependencies. I don't think Microsoft Project's going to make a revisit of this stuff. I think we can build an AI tool that could better plan it, but there's a lot of moving parts.
Yeah. I think we've seen the same, right? In projects that we've jointly worked on, where it's not traditional IT, where a box shows up, you rack stack, power it on, and off it goes. There are a lot more considerations, especially with some of the high-end liquid cool systems. You mentioned the coolers, the CDUs, etc. But just being able to build out that data center infrastructure is showing that it does take time and planning for that. So for all of the steps that you talked about, I think that is, Pradeep, what some of the things that from our experience, that you definitely have to watch out for.
Well, and the other side of that, just real quickly, is you're not just laying on a standard image and going, right? The interdependency between all of the drivers and firmware and OS and upper stack sort of acceleration, and then the AI libraries or frameworks you're using, that can be a pretty intricate deployment. And so, any variance in that can delay actual bring up. And now you got a bunch of assets sitting on the floor that can't be used,
Expensive
right?
assets.
So think about it full stack. An AI factory is really about full stack a known input and output.
Yep. All right. Last question from the time that we have, and this one's from Tracy. And Tracy asks, what's the best way to get started with our AI projects? I think that's a little bit broad, but I'd love to hear your insights on that.
Wow. So get multiple perspectives. I think, Tracy, I think, you know, certainly if IT is involved, talk to the traditional partners that have serviced your business. They know your business. They know your organization. Even just understanding procurement deployment cycles and other things in traditional IT can help remove a lot of barriers, can help bring intelligence. So talk to your current vendors, I think. Attend things like this tech talk. I mean, you can't get too much information. I live in this industry day to day and I read almost all the time, right? I'm always looking for new info, new feeds. Read the manual has been replaced by read the blog, but those blogs are critical. And then make sure there's a clear understanding. We talked about the three stakeholders, right?
Yep.
You've got your data scientists, your AI practitioners, you got your executive management, and then you've got the IT operations. Make sure you get consensus between those three about what's the goal, what's the timeline, what's the investment, envelope. And then those conversations with the vendors and looking at industry can help inform. Don't rush, but don't wait.
And I think the last thing I would just add to that, and I hear this a lot too, is really have the use case in mind.
Absolutely. I mean, we say know thy workload. If you don't know the workload, then know the use case for sure.
With that, we'll wrap up today's call. And again, thank you, John, for being here.
No, thank you, Jason. It was a pleasure. And thanks to all that were listening. Hopefully I was able to share something that was of value. And I'll look forward to following up on the conversation.
Yeah, until the next episode.
All right. Sounds good.
All right.
Thanks.